Hey everyone! So today we're going to dig into some really interesting new research that gets right to the heart of one of the biggest challenges in AI right now, security. We're looking at a new paper that lays out a pretty clever automated way to build safety into AI apps from the ground up, and we're going to see exactly how it works.
But before we get to the solution, let's start with the problem. I want you to think for a second. Of all the potential security threats facing AI applications, what do you think is the #1 thing keeping developers and security pros up at night?
And that question? Well, it leads us directly to our first big topic. Because according to pretty much all the experts, including the folks behind the OWASP Top 10 for language models, there's one threat that really does stand head and shoulders above the rest. And that threat is called prompt injection. At its core, it's basically a social engineering attack, but for an AI. An attacker crafts a sneaky prompt, a set of instructions, designed to trick the model into completely forgetting its safety rules and its original purpose, and instead just do whatever the attacker wants. You know, a really good way to picture this is to imagine a witness in a courtroom. They've sworn an oath to tell the truth. But then a really sharp lawyer comes along and uses tricky, confusing language to manipulate that witness into saying something that totally goes against their oath. The AI is that witness. It's just trying to be helpful, but it gets bamboozled. All right, so if that's the problem, how in the world do you defend against it? Well, this research paper pulls a really powerful strategy from the broader world of software engineering, and it's called a shift-left security solution. Okay, so think about how software is usually made. You have the build phase, then the test phase, and then it goes live, into production. Way too often, security problems are only found way over on the right, when the product is already live. And trust me, that's the absolute worst time to find them. The whole idea of shifting left is about dragging that security process way earlier, to the left on this timeline. You build automated security checks right into the development process itself so you can find and squash bugs before they ever see the light of day. So that's the theory. Sounds good on paper, right? But does it actually work for AI? To find out, the researchers ran an experiment to see if this kind of automated early-stage testing could actually make a dent against prompt injection. And what's so great about this is how practical they made it. They didn't need some giant, expensive supercomputer. Nope. They used a small, really efficient model, Phi 3 Mini, and ran the whole thing inside GitHub Actions, which is a tool that tons of developers already use every single day. This proves that their approach isn't some theoretical fantasy. It's something real-world teams can actually use. So, they put two popular defensive techniques to the test. First up is chain of thought. This is basically just telling the AI, hey, before you answer, think it through step by step and check for any manipulation. The second one is called few-shot learning, and this is all about show, don't tell. You give the AI a few concrete examples of what a malicious prompt looks like and what a good, safe response should be. You're basically training it to recognize trouble. Okay, so they set everything up and then threw thousands of simulated attacks at the system to see how these defenses would hold up. So, what happened? Let's get into the results. First, we need our baseline. And honestly, this is the scary number. With 0 defenses in place, the AI fell for the trick almost 69% of the time. So, that's our starting point, and it really shows you just how vulnerable these models can be right out of the box. So what happened when they added that first defensive layer? With the chain of thought instructions, the violation rate did drop, but, well, only by about 2%. It's a tiny improvement. It proves that just telling an AI to be more careful isn't a silver bullet, not by a long shot. But this is where things get interesting. Look what happened with the second technique. By actually showing the AI a few examples of attacks, the violation rate plummeted to just over 55%. That's a drop of over 13 percentage points from the baseline. This is the key insight. Showing is way more effective than just telling. So, of course, the next question is, what if you don't choose one or the other? What if you layer them together? Well, that's where they got the best result. By combining both techniques, showing the AI examples and telling it to reason step by step, the violation rate fell to about 51%. That's a total improvement of more than 17% compared to doing nothing at all. Now, you might be looking at that and thinking, wait, a 17% improvement, that's it? The attacks still work half the time. And, you know, that's a totally fair point. But this is where we have to put on our cybersecurity hats. A 17% gain is a huge deal because it validates a core security principle called defense in depth. The idea, as Mist puts it here, is that you never rely on just one wall. You build layers, so an attacker has to break through multiple defenses. This is a crucial first step. And this brings us back to the real magic of that whole shift-left idea. Because this system isn't just about measuring risk. It's about using that measurement as an actual automated gatekeeper during development.
And this is what it looks like in the real world. This is a screenshot from GitHub. And as you can see, that automated security test has failed. And because it failed, look at that. The merge button's grayed out. It's blocked. This physically stops a developer from pushing code that doesn't meet the security standards.
So here's exactly what happened in this case. The team drew a line in the sand. They set a policy that said the AI's violation rate had to be 15% or less. But the automated test came back and said, nope, the violation rate is actually 56%. Because it failed to meet that policy, the process grinds to a halt. The developers have to go back to the drawing board and beef up the defenses before they can even try again. Security becomes non-negotiable.
Okay, so let's zoom out for a second. What's the big picture lesson here? What does all this research tell us about the massive challenge of keeping AI systems safe?
I think it boils down to 4 really crucial takeaways. First, and this is the big one, there is no silver bullet here. Even the best defense they tried still let about half the attacks get through. Second, because of that, defense in depth is everything. Layering different controls is our best bet. Third, that shift-left idea really works. Automating these checks early and often is a practical way to build safer systems. And finally, number 4. Security isn't something you do once. It's a never-ending cycle of testing, measuring, and getting a little bit better each day.
And all of that leaves us with one last massive question to think about. This research shows us a real, practical path forward, but it also shows us just how hard this problem is. So if our best layered defenses today still give us these kinds of modest, incremental improvements, what completely new, out-of-the-box strategies are we going to have to invent to truly protect the incredibly powerful AI systems that are just around the corner?